In a previous video, I demonstrated VLAN configuration on an Arachnus infrastructure. I created 4 VLANs and enabled Inter-VLAN routing between accounts, human resources and a server. But enabling Inter-VLAN routing opens up the entire subnet range. If I had a dedicated server VLAN on my network and the HR server was on 192.168.254.10 and the account server was on 192.168.254.20 and Inter-VLAN routing was enabled between HR, accounts and the server, all the hosts on HR and accounts can communicate with either server and potentially access the wrong resource, as well as the hosts on the HR and the accounts VLAN being able to communicate with each other. So we need a way to limit access across VLANs so only certain devices and hosts can reach certain resources. In this demonstration, I'm going to create a few VLANs: accounts, security and server. The server VLAN is going to host a local Windows server and also host a IP camera. Plan is to allow accounts to access the Windows server and security to access the IP camera, but security won't be able to access the Windows server and accounts can't access the IP camera. Then we take it one step further. At the time of recording this video, there was a few headlines going around where government agencies were able to collect data on Chinese manufactured cameras. So with this in mind, we want the IP camera to be accessible on the local area network, but not have any connection out to the World Wide Web. So I'm going to go ahead and configure a few VLANs. The default VLAN will contain the router, switches and the wireless access points, the accounts VLAN, a security VLAN and the server VLAN, which is going to contain the network server and the IP camera. I've got an in-depth video on the VLAN configurations, so I'm not going to explain too much about that in this video. So VLAN configuration is VID1 is default VLAN, accounts is on VID10, security is on VID20 and servers are on VID30. On my router, if I go to clients and services and look at the ARP table, I can see my server has obtained an IP address of 192.168.30.102 and the IP camera has an IP address of 192.168.30.101. If I connect my laptop to a port that's configured to be on the server VLAN, I can type in 192.168.30.101 and access the camera's web UI. If I then go to 192.168.30.102, I can access a basic local web server. If I now go to the accounts VLAN, my laptop's obtained an IP address of 192.168.10.100. If I try and connect to the server, the page just hangs. And if I try and get to the IP camera, the same result. If I now connect to the security VLAN and run the same test, get the same result, proving that these VLANs are completely isolated. So how can we communicate from these two VLANs to the server VLAN without enabling inter-VLAN routing? Well, we can use an access control list, and in this instance, access control lists at layer 3, the network layer. In general, ACLs are rule-based lists which permit or deny traffic from accessing a certain resource. As a really simple example, Gareth can access a file on the company's server, but only has read permissions and cannot write to that file, whereas David has permissions to read and write to that file because he is permitted to do so based on the access control list. There are many flavors of access control lists, but we want to focus on layer 3 ACLs. ACLs can provide better traffic management, add an extra layer of security to your network, and save on network resources. We can use a layer 3 ACL to route information across VLANs based on a single IP address or an IP range. So first of all, we need to allow the host on the accounts VLAN to access the web server on the server VLAN. On my Arachnus router, if I go to advanced and ACLs, I'll create an ACL and I'll call it server access. Priority is the order that the ACL is working. If the packet matches, the rule of priority 1 is actioned. If it doesn't match, it moves to the next priority, where if it doesn't match or doesn't exist, the packet is blocked. So action set to permit and service to all traffic. I'll set the incoming and outgoing interface to LAN, as this internally is routing between the LANs. The source I'll set to range, as there may be multiple people working in the department, each needing access to the server. So I'll set the range to 192.168.10.100 to 10.110. Destination is the server IP and my server is set to 192.168.30.102. I've got the option to schedule this rule so the user can only access the server, say in working hours. On this occasion, I'll leave it as always active, hit apply and wait for the config to save. Then I'll create a second ACL so the security team can access the security cameras from their VLAN. So back to the router, add an ACL, and priority 2, and action permit. And I'll set the service to HTTP so they can access the web UI. Again, set the incoming and outgoing interface to LAN, and select the IP range for the incoming interface. Again, there might be a couple of security workers, so I'll set the ranges as 192.168.20.100 to 103. I can adjust my DHCP scope accordingly to only allow for, say, 3 DHCP hosts on that particular VLAN. And I set the destination as the camera, which is 192.168.30.101. And we're done. So if I go to my accounts VLAN and verify I'm getting the correct IP address, so I'm getting 192.168.10.100. Then I'll go to my web browser and type in 192.168.30.102, and I'm directed to the web server. Now if I try and connect to the camera on 192.168.30.101, I get no web UI display and the connection is just hanging. If I now connect to the security VLAN and check I'm getting the correct IP address of that range, so I'm getting 192.168.20.100, and type in the IP address of the camera, which is now 192.168.30.101. I can get to the UI of the camera and I can log in. But if I now try and go to the server on 192.168.30.102, connection just hangs and eventually be refused. So this is a really good way for resources to communicate between VLANs. I've used Inter-VLAN routing for years, but if you want to add just an extra layer of security to your network, ACLs are great because anything that doesn't follow the rule is blocked. Whereas with Inter-VLAN routing, the entire subnet range is opened up. So if Inter-VLAN routing is enabled between accounts and the server VLAN, but on that server VLAN was a file server with sensitive information on it, anyone from accounts could potentially access that file server. I've also tested the access control list on a Control 4 environment, so I was able to successfully drag the IP camera stream into the project and view the stream on the interface. I mentioned earlier that I'd like to add another layer of security and block the IP camera from accessing the outside world. This may be because the customer's got an on-site security team who don't need any sort of external monitoring, or the customer could be paranoid about having their information collected by the cameras from government spies. You potentially could create a secure VPN tunnel to the default management VLAN and then create an access control list to say devices in the DHCP range of the default VLAN can route across to the camera VLAN and be able to view the cameras remotely. So I'll go back to the router and go to ACL, and I've created a WAN deny ACL. I've set the priority as 1, which moves the other ACLs down the list, and the action to deny, and all traffic. The incoming interface is any, and the outgoing interface is WAN1. The source IP is the IP address of the camera, or in this instance it'll be my laptop so we can see the ACL in action. And the destination is any. You could configure this as a range, so if you have multiple cameras on the network, they all get blocked from accessing the outside world. So I'll connect to the server VLAN and check and get the right IP address. My IP address is 192.168.30.104. If I go to my browser and go to bbc.co.uk for instance, the web page just hangs, proving I can't connect to the internet. So I want to check to see if this will work on the camera. So if I connect back to the management VLAN and change the IP address in the ACL WAN deny to the camera's IP address of 192.168.30.101. But before I press apply, I'm going to disable this ACL and then check to see if I can connect to the Hikvision cloud services. I then connect back to the server VLAN, my IP being 192.168.30.104. I'll go to the camera on 192.168.30.101. Hikvision cameras use HikConnect as their cloud platform to connect to cameras remotely. When I enable the feature, the status changes from offline to online. If I go to the email page, I've already filled in the SMTP fields, and I can also send a test email. So I've received an email on my phone from the camera, just proving that it can connect out to the SMTP server. If I now go back to the default VLAN and apply the ACL and connect back to the server VLAN, my laptop can now get out to the internet. If I now go to the camera and restart the HitConnect service, we can see that the HitConnect service is now offline. I'll do a couple of refreshes and it still says offline. When I go to the email feature and try to send an email, it just hangs and eventually it will time out and it says failed to connect to the test server. So I hope this video has been able to explain how to communicate across VLANs without the need of using Inter-VLAN routing. Access control lists are a great feature to use and also add extra layer of security to your network.